We can use the relationship of the a value and the b value in a quadratic function, and I just want to put a little caveat here. Okay, this is for the general function. So the general form. To find the x value of the vertex given the equation in the general form. So we have negative b over 2a. Interesting. That kind of sounds like the quadratic formula. I wonder what's going on there. Given the x-intercepts, or the function is factorable, or if the function is factorable, we can find the x value of the vertex. The x value of the vertex is the midpoint between the y-intercepts, and we have familiarized ourselves with this. So you take the first x-intercept and you add it to the second x-intercept, and you divide by 2, and x equals x1 plus x2 over 2. So this is the equation of the line. Remember, we have to state it as an equation. So let's use what we've learned up here to check our work in this question here. So determine the coordinates of the vertex of the parabola with the equation y equals 3x squared minus 12x plus 7. So we have already done this work. We know that the equation in standard form is y equals 3 times x minus 2 squared minus 5. So I can look at this right here and say, well, I already know what the vertex is. It's going to be at 2 and negative 5. But what happens when we say that the x value of vertex is negative b over 2a? Now, my b is 12, or sorry, my b is negative 12, and my a is 3. So all I'm going to do is I'm going to substitute those values in. So the x value of the vertex is going to be negative 12. I'm going to use color again so you know where this is all going. Over 2 times 3, which I am going to also use yellow one, just so you know where everything comes from. So then I say, oh, gotta change back to my black pen. So then I say x equals positive 12 over 6. So the x value of the vertex is 2. And look at that. Okay, I'm going to celebrate using fuchsia because that is my favorite color. That is no coincidence. Okay, so even though we did factor here, this is an alternate method to find the x value of the vertex other than getting it in the standard form. So what we then do is we sub into original equation and solve for y. So I'm going to say y equals 3 times 2 squared minus 12 times 2 plus 7. And I'm just going to use that fuchsia again whenever we have this 2 so you know where it comes from. So then y equals 3 times 4 minus 24 plus 7. Y equals 12 minus 24 plus 7, which indeed is negative 5, which I'm going to color in green, just like that. So yes, I can restate after this that my vertex is 2, negative 5.